Okay, so going forward to NAT, and this is really where you start, and SBC really becomes important. So NAT is basically it's a network address translation, and it's a tool used by network administrators to minimize the footprint on the internet environment. So instead of every computer connected directly to the internet, which requires an IP address, which is a limited resource or is quickly becoming one, at least until we move from IPv4 to IPv6, you put a NAT device in between the internet and your office. And so every machine in your office can share a single outbound IP address that the internet would see. Um, so while this works great for computers, it's not compatible with the protocols that VoIP uses. If you have NAT on your network and you want to use VoIP, you got to use some tricks. And since nearly everyone is using that, it's important to have these tricks kind of up your sleeve. So um, what it boils down to is the SBC does the tricks for you. So if it's been properly configured. So the session border controller is a network device that, again, kind of the same way a firewall is. It's installed between your your local network and the internet. It does hosted NAT traversal. Sometimes people just refer to an HNT or registration caching, and it allows you to provide service to customers using NAT. Um, it also protects your VoIP services, so it prevents unauthorized devices from accessing your network. It can even protect your network from attacks launched by your own subscribers. The SBC is essentially the VoIP traffic, what a traditional data firewall is to data applications. And the way that it would, going back to the whole the subscribers thing that I was just saying, the way that it would do that is you could set limitations, and you could say, hey, I only allow this subscriber to have 10 calls per second, or so many concurrent calls, or can create so many calls at a given time, and so it could block that based on that behavior. And the last thing is VoIP peering. So it lets your core network have access to outside partners and peers, such as a SIP access to PSTN access provider. Okay, so hacking. What about the VoIP CPE? So this is the customer premise equipment. So um, the the SBC, if a hacker launches an attack against a VoIP CPE, what protects them? Realistically, nothing. Most people, they don't have a firewall at their house, and the SBC is in between the internet and your core network, not the internet and the customer's local area. So it effectively, it doesn't really do anything for them. Um, but the upside of that is that a single device, a hacker generally is not going to go not going to go for a single device, because it's a low value attack for hackers and essentially for network operators. It is possible to provide some protection by using a stateful CPE firewall, like a Linksys or a Netgear. Juniper and Cisco also make firewalls that can protect against voice CPE attacks, and most firewalls perform NAT by default. So you would have to have NAT traversal if that were implemented, which again, that's what SBCs are good at. So we go back. We got our malicious hacker guy with his sweet hacker gear on, and we can't see him. But what quickly, I guess what I'll talk about quickly is that you'll see that let me see if I can get this pen to work. So the way we've got it described here, everything that's within this red block would be protected by the SBC. Everything that's in this blue box would be protected by your standard firewall, and then everything in the purple box would be protected by your F5. So the only other thing that's kind of out of the network that I would bring up is that you have off to the right, you have a user agent that I will circle in magenta. You have a user agent that doesn't have any sort of CPE. firewall set up, so they would have no sort of protection. Statistically speaking, a hacker's not really going to go after them. Um, but but if they did, the firewall that I'm going to mark here with, or the user that I'm going to mark here with green would actually have some sort of protection from that hacker. Okay, clear that. So the SBC is as a security device. The SBC is often seen side by side with the firewall. So you can't have a firewall and it perform the same functions as an SBC, and by the same token, you can't have an SBC that performs the same function as a firewall. But whereas a firewall has essentially a trusted and untrusted side, or an interface that's, one side's trusted, one side's untrusted. You have the same thing on an SBC. So the SBCs essentially, they handle the RTP, uh, which is sent, basically to any UDP port. The SBC also monitors every call entering and exiting and understands exactly what the call is supposed to be doing. It can block signaling from um, unknown devices on the internet. And then going back to what I was talking about earlier, with the overload protection, they can rate limit traffic to reasonable limits. So for instance, if you know your call server can only handle 10 calls a second, then you would want to configure your SBC to block any more than 10 calls per second. So in this way, the SBC functions as a fuse, if you want to view it that way, to protect components against overload. It may be better to block traffic than to crash the server effectively. Even registered unauthorized devices can malfunction and flood a system with calls. I've seen it happen several times.